Hello class and welcome to arithmetic time. We're just going to start out today by doing a little bit of review and then looking into our book, which will be lesson 151. I want to make sure I have the number right. 151 for our arithmetic lesson. Do you remember these? Factor, say it with me. Factor, partial product, product. Good. How about this one? Addend, sum. Minuend, subtrahend, difference. And again, factor, product. Did we get all those right? I believe we did get all of those correct. I want to make sure that you remembered those. What about these? 1 pecked equals 8 quarts. Who said 8 quarts? That's one that we need to really work on and memorize because I don't think everyone knows that one. So make sure you memorize that one. 1 peck equals 8 quarts. Kilo means 1,000. Hecto means 100. Deca means 10. Deci means what? 1/10 or 0.1 as a decimal point. Centi means 1/100th or what? 0.01. Milli means 1/1000th or 0.001. 1 centimeter equals 10 millimeters. Did you get that one correct? Because there's the difference between milli and centi is 10. Each one away from the other one is 10 for each one away that you would go. 1 ton equals 2,000 pounds. 1 minute equals 60 seconds. 1 foot equals 12 inches. 1 yard equals 3 feet. 1 what? Quart equals how many pints? 2 pints. 1 metric ton, what was that one? 2,200. Who got that right? Raise your hand. Good for you. 1 meter equals 1,000. Make sure you can see that. 1,000 millimeters. 1 kilometer equals 1,000 meters. 1 decade equals 1 decameter equals 10 meters. 1 hectometer equals 100 meters. 100 meters. 1 meter equals 10 decimeters. 1 dozen thing equals 12 things. 1 meter equals 100 centimeters. 1 kilogram equals 1,000 grams. Do you know them this quickly? I hope so. 1 peck equals what? 8 quarts, and hopefully you got all of those correct. Now I'm going to show you a fraction. I want you to reduce it. 2/4. Did you say 1/2? 3/4. 2/3. See if you can say them before I do. 1/2. Good job, Michael. I know you got it right. Good job, Richard. I know you got it right. Who's got this one? 5/15. Colin? 1/3. And you should have said, everyone, 2/5. Who got that one? What number were you thinking of with 820? 820. What would go into 8? 4 goes into 8 2 times. Can 4 go into 20? Yes, 5 times. So 2/5 is the answer. And there's more of them, but we won't do all of them this time. Now I have some that I want you to change to a decimal. 4/10. 0.4. You got that one. 120 thousandths as a decimal. 0.121. Tenths, hundredth, thousandths, right? Okay. 131 thousandths. Be what? Tenths, 100 thousandths. So 0.131 written as a decimal point. 9/10. How would you write that as a decimal? 0.9. 11 thousandths. How would you write that as a decimal? Now, thousandths, you need 3 places. So you can't just put 0.11, can you? So what do you have to do? 0.011. You have to have a placeholder to get to thousand. And you wouldn't put the 0 in the end, because then you'd be saying 110, which is 110, right? And, you know, it's 11 thousandths, so you have to put the 0 there for that one, okay? Keep working with decimals. If I went this way, what if I went, and did some mixing? What if I gave you the decimal and you had to write the fraction? 2.3 would be 2 3/10, and do it the other way, okay? So we'll keep practicing those. Your shapes. Let's start with this one. What's that? Say it out. Perpendicular lines. What are these? Congruent angles. Say it before I do. Right angle. Ray. Line. It's got the arrows on the end. It could be going indefinitely in any direction. Line. Line segment. If it's got the points at the end, line segment. And this would be point, right? Point. Angle. This is just an angle, but it could be any angle. It's not a particular kind of angle. It's just an angle. Okay? Could be big, could be small, but basically 2 rays put together makes an angle. What shape? It's a plain shape, but we call this a rhombus. Rhombus. How about this one? Parallelogram. Parallelogram. Trapezoid. Now, a trapezoid, if you went there, you could have just a rectangle, but this side's longer, so you have this diagonal slant there. So remember that for what a trapezoid is, and I want you to learn that one now. Trapezoid. Rectangle. Rectangle, 90-degree angles in each corner. Circle, of course. Triangle, of course. Square, of course. And you know it's a square, perfect square, if there are perfect right angles in the corners where you see a square in each corner, meaning it is a perfect right angle. Lines. What kind of lines? Did you say parallel lines? Good job. Parallel lines. And that takes us to all of those. Set those down. Now I want you to draw your attention to some things here. Can you see that? That there is a mathematical equation where we're solving the unknowns. I want us to go over how to do that to make sure you've got it and you've got it well. So what I'm going to do is I want you to look on my paper to do this part, all right? So what I'd like you to do is look at this paper. 9 plus 8 equals 6 times 12. Let's review this. What's the first thing you do? Did you say, write the part you can write, or solve the part you can solve, and just copy everything else just as you see it? N plus 8 equals, and then write the part you can solve. 6 times 12 equals 72. Got that? Now let's rewrite it again, doing the opposite of what you see here. But you still copy this, and I scoot over a little bit. In plus 8, and then write the opposite of plus 8, minus 8 equals 72, and whatever I just put, I put again on this side. What I do to one side, I must do to the other side. If I subtracted 8 on this side, I must subtract an 8 on this side. Now, plus 8 and minus 8 just leaves us with nothing. So we just have n, but there's no number there. We call that canceling out. Line up the equal sign, and then let's think of minus 8. Can you do that? So 72 minus 8. What is 72 minus 8? And what is it? Who said 64? 63, 64, 65? Who thinks it's 64? All right, there you go. Now, some of you, I've noticed when I do ones like this in class, you have to think on a one like that with a bigger number. And if you have a harder time, I always tell you can't always do that, but you need to get where you can do it in your head. But you could do that if you wanted to, and you would get 64. But you should get to where you can do 72. What's a great way to subtract 8 from 72 in your head? If you think of the next 10 down, right? Because you only have 2 in the 70s, right? And you know there'd be 6 more, right? And 6 from 10 is 4, so it has to be that. So different people are having different things go through their head when they're subtracting mentally in their head. But you need to know the numbers. You need to know the numbers that if, let's say there wasn't a 7 there and there was just an 8, you would have had to borrow, right? And 12 and 8 would be 4. And the next less 10 would be a 6. I hope that didn't confuse you, but whatever it takes for you to get the right answer quickly. It is 64, but let's check to make sure it is 64. I'm going to draw a line. And anytime I see an N, I'm going to insert a 64 and rewrite this equation sentence, call it an equation sentence, down here. So N equals 64, so I'm going to write 64 plus 8 equals 6 times 12. Put our equal sign. What is 6 plus 8? Is it 72? Yes. 8 plus 4 would be 12, and then the 1 would make 7, right? 72 is 6 times 12, 72. We had that from before. It equals the same number, therefore it is correct. And that's our measurement, or not measurement, but that's our unknown, solving the unknown equation. Now, in your book, you will see a story problem, okay? And you're going to be talking about Miss Balcom. Miss Balcom, and that story problem A, she works 7.5 hours each day, 5 days a week. So she's working 5 days a week, all right? How many hours would she work for 4 weeks? Okay, I'm going to say that again. Are you with me? Your mind's not wandering somewhere else, are they? Is it? 7.5 hours a day. Now, don't just say, oh yeah, 7.5 hours a day. What does the story problem ask us at the end? How many hours would she work for 4 weeks? And right now, some of you might be thinking, for 4 weeks, all I know is how many hours I'm working today. You have to figure out how many you'd work in 1 week, before you can figure out how many 4 would be. So until we can figure out how many hours would be in 1 week, we can't figure out how many would be in 4 weeks. So first, find how many hours she would work in 1 week. Well, it tells you, doesn't it? 5 days, that many in each day. So there's several steps here. First, let's figure out how many she worked that week. And how would you do that? Richard, I know you got the right answer there, right? Naomi, what did you get? Tell me what you will do. 7.5 hours in one day, but there's 5 days. So 7.5 hours they worked one day. They worked it on Tuesday. They worked that many on, for 5 days. Therefore, it's going to get bigger. So I'm going to multiply times 5 to get how many hours would be in 1 week, 5 days. Remember, when you multiply by a mixed number and a whole number, we always put a 1 under our whole number. Then let's change this to an improper fraction so that we can do our multiplying here, or it's going to be harder. So 7 times 2 is 14 plus 1, 15. And our denominator stays the same. We're going to make it an improper fraction and multiply it by our 5 over our 1. If you can cancel, do. If you can't, and then just multiply and get an answer. That's how many hours she would work in 1 week. Okay? So you'll have to multiply that. You might want to come over and multiply it like that if that's maybe a little bit easier. Put that as your numerator. Then put that as your denominator to get 1 week. Then, once you figure that, that's per week. That's how many hours, that's going to be per week, right? That's how many hours you worked for each week. But we want 4 weeks. So once we find that answer, what do we need to do to get 4 weeks? We're going to have to multiply again, aren't we? By what number? 4. And then you'll get the total number of hours per week. So you need at least 3 answers. You need this answer, right? You need the total for each week. You need your work, okay? You need this answer. But then you also need another answer for the total for 4 weeks. See? Now, that does take some thinking through because you have to go through several steps in your head in order to do this. So hopefully you can do it. I know you can. I know you can. So you work on it and you get story problem A. Now, story problem B requires you do A. If you don't do A first, you cannot do B because it's Miss Balcom again. She paid $10.33 per hour. That's how much she gets paid per hour. How much does she make in 4 weeks? First, we have to know how many hours she made. So once you solve A, you'll be able to do B. You'll get this, let's say she worked this many hours for the 4 weeks. Then you'll be able to get how much money she made in those 4 weeks. Does that make sense? You'll know how much money she made. But you have to solve A first. You have to multiply all this out. Multiply that by 4. That's how many hours. And then once you get your total number of hours for 4 weeks, what are you going to do with the $10.33? Are you going to divide or multiply? Well, if that's for 1 hour, and you've got 100 hours in a week, or 60 hours in a week, or however many hours in a week, or 50 hours, whatever the number is, yeah, you're going to have to multiply, aren't you? Because it's going to get bigger. It's going to get bigger because that's 1 hour. And if you have got 60 hours or 55 hours or however many it is, it's going to get bigger, isn't it? So think through it logically. You can't do B until you do A, but solving A will help you get the answer for B. Then, of course, you need to multiply. You need to know how to divide. You need to know how to add and subtract fractions as you do review lesson 151, which go ahead and send it to me. I want to see how you're doing so that you will be ready for quizzes and tests in arithmetic class, okay? So you go ahead and do that. So keep practicing, keep looking at everything that we've talked about today, and do a super job on your paper. It's a review lesson, and if there are any troubles, parents, students, whatever kind of problem maybe you need extra practice with, and you say, I just don't quite get that, I keep messing up on that, please let me know and I will incorporate it in the next video. But until next time, you be looking. And oh, by the way, on Schoology, if you go to Schoology, all the videos are there. Should be blue, right? There was some asking about that. If you click on the word, it should take you right to the video, or you can go to YouTube and you can type the channel NLCA of Rocky Mount, find our school channel, then go, it should be on the left side, it's backwards on the video, but anyway, look at the left and you should see, depending on the configuration of your screen and whether it's an app, it might look different, but look for the word playlists. Once you go to NLCA of Rocky Mount, then find playlists and find fourth grades, Mr. Doyle, or actually Doyle4, it should say, Doyle fourth grade, all right? And then all the videos, and find the date for today's date or the date you're wanting to watch and the subject, and you'll be able to watch that video. Or you can go right to Schoology and click, and that'll be even easier to take you right to the video, or should, if the internet's up and working correctly. All right, until next time, be looking for the next video. You take care, and God be with you.